Okay, for this next video, we're gonna talk about two rules in differentiation that are very, very important. Okay, the first rule that we're gonna talk about is called the product rule. Right? The point of this rule is we're finding the derivative of a product of two functions. Okay? So what is the product? What is the derivative of a product? Now, the rule is that it's equal to f of x times the derivative of g of x, so g prime of x, plus g of x times the derivative of f of x, f prime of x. Okay? Or more concretely, so succinctly, I guess is the correct term, fg is equal to fg prime plus gf prime. Okay? Now, you might still have difficulties in remembering that. The mnemonic is, let's call this the left function, let's call this the right function. Okay? The mnemonic is left d right plus right d left, or LDR plus RDL. Okay? So the product rule is in essence left d right plus right d left. So for example, what is the derivative of, say, uh, x plus 1 times x squared? Just an example. Okay? So there are two ways to solve this. The first way, of course, is you can distribute, but that that would be okay as well. But let's do the product rule. This particular example, this is the left, and this is the right. Okay? So if we do left d right plus right d left, this is left times the derivative of right, which is x. What's the derivative of x squared? It's 2x plus right x squared. Times the derivative of the left, which is the derivative of x plus 1, which is 1. So times 1. So x squared times 1. If you simplify this is equal to 2x squared plus 2x plus x squared, which is equal to 3x squared plus 2x. Okay? So in essence, that's the product rule. Okay? Left d right plus right d left. Another example. Uh, the derivative of 2x cubed plus 3 times x to the fourth minus 2x. What's that derivative? The first solution again is you can do FOIL, like simplify this using FOIL, like multiplication. But let's do the product rule. Okay, when you're given an obvious left and right function, you need to do a product rule. Oh, well, you don't need to do it. It's like it's preferred if you do a product rule. So this is left, this is right. So in this particular example, what is left d right? So left times d right. So what's the derivative of the right? This is equal to 4x cubed minus 2, if I'm not mistaken, plus right, x to the fourth minus 2x, d left. 2 so what's the derivative of 2x cubed? That's 6x squared. Okay. Then of course, you need to simplify this, right? So this is 8x to the 6 plus 12x cubed minus 4x cubed minus 6 plus 6x to the 6 minus 12x cubed. So the final answer is 14x to the 6 minus 4x cubed minus 6. If I'm not mistaken. Right? So again, the product rule is left d right plus right d left. 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 Okay? Right. Next. The next rule is called the quotient rule. Okay? So, like the product rule that tackles the derivative of a product of two functions, quotient rule is tackling the derivative of a quotient of two functions. So f of x over g of x. Okay? Now, the way to solve this is how do we solve this? I'm gonna write the formula first, then I'm gonna give an mnemonic. So this is g of x times f prime of x minus f of x times g prime of x all over g of x squared. And you might be looking at this and you're like, whoa, that's not as hard to remember. That's harder to remember than the product rule. Because if you remember the product rule, it's just left d right plus right d left. Kind of true, but there's a mnemonic. The way we do it is, let's call this function as high. Let's call this function low. Okay, so we're finding the derivative of high over low. So this is just gonna be low d high. Okay, low d high minus high d low all over low squared. Okay, again, the mnemonic is low d high minus high d low all over low squared. Low d high minus high d low all over low squared. Low d high minus high d low over low squared. Yay, yay, yay. Low d high minus high d low over low squared. So that's the mnemonic for quotient rule. Okay. So for example, what's the derivative of 2x plus 3 over 3x plus 5? So in this case, you need to identify what is the low, what is the high. So this is the high, this is the low. Okay. By the way, if you want like a simpler version, this is g f prime minus f g prime all over g squared. Okay. So back to this example. So we just use this. Don't forget the low squared. Always write the low squared first because people forget the low squared. People remember the low d high minus high d low, but people forget the low squared. So what you do, you write the low squared first. Okay. Now, low d high, so low times the derivative of high. So what's the derivative of 2x plus 3? That's 2. Then high, 2x plus 3. D low. So the derivative of 3x plus 5, that's 3. So that's 6x plus 10 minus 6x plus 9, or 3x plus 5 squared. And finally, this is equal to 6x minus 6x is 0. 10 plus 9, 10 minus 9 is 1. So this is 1 over 3x plus 5 squared. Okay. How about what's the derivative of 2t all over 4 plus t squared? When you see something over again, okay, 5 seconds, you can pause to try. Answer in 5, 4, 3, 2, 1. Again, do not forget the row squared. Write that first. Okay. Then it's row d high, 4 plus t squared times d high, which is the derivative of 2t, which is 2, minus high, 2t, times the derivative of low, which is the derivative of 4 plus t squared, which is just 2t. So if you simplify that, 8 plus 2t squared minus 4t squared, which is equal to 8 minus 4t squared, no, sorry, minus 2t squared all over 4 plus t squared squared. So this is the final answer. Okay? Easy. Easy money. What's the derivative of x cubed over 1 minus x to the fourth? Just as an example, right? Again, answer in 5, 4. Pause here if you want to answer, to try to answer. Answer in 5, 4, 3, 2, 1. So it's again just rho squared. Okay. Rho d high. So 1 minus x to the fourth times d high, which is just 3x squared, derivative of x cubed, minus high times the derivative of rho squared, which is negative 4x cubed. Negative 4x cubed. So this becomes 3x squared minus 3x to the sixth plus 4x to the sixth over 1 minus x to the fourth squared. Guys, don't forget the negatives. Huh? This negative right here, it gets transported here. Negative times negative is positive. Also, do not forget your laws of exponents. When we multiply exponents like x to the fourth times x squared, we add them. It becomes x to the sixth. Okay? So the final answer is 3x squared minus plus x to the sixth all over 1 minus x to the fourth squared. That's it. Okay? Yeah. Last example. Last two examples. Find the derivative of x plus 1 times x plus 2 times x plus 3. Okay? Now, this is kind of weird because you have three factors right here. Okay. I guess that was a spoiler, but try answering it first. Answer in 5, 4, 3, 2, 1. Okay. Now, this is kind of weird because there are three factors. It's not obvious what the left is, what the right is. But what you can do is do this. This is your left, and this is your right. Just as an example. Okay. Of course, there are many other equally correct. So you can let this be the left, let this be the right. In fact, I suggest you to try the both. Okay? It should give you the same thing. But what we're gonna do here is let's try this second one right here. So left d right. In this case, left d right. So what's the derivative of right? That's just 1. Plus right times the derivative of the left. So we're finding the derivative of the left right here. X plus 1 times x plus 2. So as a scratch, I guess, of x plus 1 times x plus 2, you kind of need to do a second uh, product rule. In this case, left d right, so left times d right, which is just 1, plus right times the derivative of x plus 1, x plus 2. So this is just 2x plus 3. Okay? So this becomes x plus 1 times x plus 2 plus x plus 3 times 2x plus 3. Again, we input this here. Okay? And of course, you can simplify this. X squared plus 3x plus 2 plus 2x squared plus 9x plus 6. Okay, using FOIL. Do not forget your FOIL. And the final answer is 3x squared plus 12x plus 8. Okay, check. So I guess check if same, if L is equal to x plus 1 and R is equal to x plus 2 times x plus 3. Check if your derivative is the same. Okay? But of course, you can uh you can do the multiplication like at the on the onset, then you can avoid the product rule. Definitely, right? But that's not fun. Okay. So for this set of items right here, what we did was we talked about the product and quotient rule. Right? See you in the last video on probably the most difficult rule of all. See you.